Hi, in today's video, we will be installing Istio Mesh across multiple primary clusters on different networks, and we will be verifying the installation. Let's check the architecture of multi-cluster, multi-primary, and multi-network. So in this configuration, we have Istio service mesh across two different networks and across two different clusters. So one Istio control plane is in cluster 1 on network 1, and another Istio control plane which is running in cluster 2 on network 2. There are two services, service A and service B, which do not talk to each other directly, but they communicate indirectly across cluster boundaries via the dedicated east-west gateway. So here you can see service A is not calling service B directly, but all the calls are going via east-west gateway. Similarly, if service B has to call service B, the call will be going via the gateway. And this cross-cluster communication is secured via MTLS. And another thing to note is there that both this control plane, they are observing each other using the API endpoints, which are the API servers. So cluster 1 is observing the API servers in cluster 2 for the endpoints, and vice versa. Control plane in cluster 2 is communicating via cluster 1 via the API server. So this is the architecture of multi-primary, multi-cluster, and multi-network Istio service mesh. We will now start the installation step. So let's start with the setup. Firstly, we need to create two Kubernetes cluster using Kind, and we don't have to override anything. So the default Kind create cluster command should work. And so Kind create cluster. This will create a cluster for us with the name cluster 1. Once this cluster is up, we need to create another cluster called cluster 2 and wait for a minute for clusters to get started. Okay, so now our cluster 1 is created. Let's create cluster 2 and give it a couple of minutes for cluster 2 to get started. Okay, so now our cluster 2 is also created. To verify, let's check the list of cluster. Find get clusters, and we have cluster 1 and cluster 2 running. We can also check in our Docker desktop. So here you can see we have two clusters running, cluster 1 and cluster 2. So let's move on to the next step. So for next step, we need to install MetalLB because we will be establishing connection between these two clusters locally. So we need to expose some services as load balancers. And in order to create a load balancer like application and assign to external IP, we need to install MetalLB. Let me go to the MetalLB installation documentation here. So here, let's copy the installation manifest from here, and first let's install it in cluster 1. So context will be kind cluster 1. So this will install the MetalLB in cluster 1. And once this is done, we need to do the same for cluster 2. So let's change to cluster 2 and install in cluster 2 as well. Okay, so MetalLB is created. Now we need to assign IP range for MetalLB so that MetalLB can assign the IP to our ingress east-west gateway for in order to communicate. So let's first check the Docker network. So I'm checking for my Docker network. So here we can see it's 172.19.0.0.16. So this is the CIDR addresses. We need to assign one for our cluster 1 east-west gateway and cluster 2 east-west gateway. Let me show you the MetalLB YML file that I have. So this is the configuration file that I have for MetalLB. So here in the addresses, we need to assign a IP range, IP pool range. So since I have 172.19.0.0, I am assigning it an IP of 172.19.255.150 to 199 for cluster 1, and for cluster 2, 200 to 250. So using this, MetalLB will assign one IP for our east-west gateway load balancer. Let's configure the MetalLB. So I have the command ready. So we are running kubectl apply -f cluster1 MetalLB.yml in kind cluster1, and it should configure MetalLB to use those IPs. Same we need to do for cluster 2. Just modifying this command for cluster 2. Okay, so now these two are done. Before we begin installing Istio, we need to do one more prerequisite, which is defining the trust between these cluster. So to do that, we need to create certificates and use those certificates for these Istio clusters. Let's first create a namespace for Istio. So here I have a namespace YML file, kind namespace, metadata Istio system, and we need to label it with topology.istio.io/network as network 1. So this is for cluster 1. Similarly for cluster 2, we have network 2. So let's create these namespaces in their respective cluster. So let me just copy the correct command. So kubectl apply namespace.yml in cluster 1. Okay, I need. Okay, so Istio system namespace is created. Similarly, we need to create for cluster 2 as well. Let me change it to cluster 2. And finally, we have created the namespaces. Now we can go for certificate configuration. I'll be going to my Istio directory, Istio installation directory. This Istio you can install following the documentation. And once you have downloaded the zip file and extracted, you will have a folder like this. Go inside that folder, and next up we need to do the CA certificate plugin. So what we will be doing here is we will create one root CA and create two intermediate CA and plug them into cluster 1 and cluster 2. So now using these intermediate CA, the cluster can communicate with each other. Let's follow the documentation. First, let's create a certs directory. I should already have that directory, so I'll just delete it. Yes, and now let's create certs directory and go to that directory, certs, and next step, generate the root certificate. I'll be copy pasting the CMD, and it should create a root CA and the key file. Okay, it's created. Next up, let's create the intermediate CAs for these clusters. Paste it. So this file will create intermediate certificates for cluster 1 and store it in a directory called cluster 1. Let's give it a moment. And it's done. Let's do the same for cluster 2. and it will create intermediate CA for cluster 2 and store it in a cluster 2 directory. Let's see if these created. Yes, we can see cluster 1 and cluster 2 are directories, and here we can see the root CA and the key file. Let's go to the cluster 1 and we can see the CA certificate and CA keys. Let's come out. Next up, we need to plug in these to the clusters. So I have the CMD here. Basically, we need to run this command. Okay. So let's paste it here. So this will plug in the certificates into cluster 1. Same we need to do for cluster 2 as well. The same for cluster 2. Okay. Now both our clusters are ready. Next up, we need to install the Istio. So I'll be going here, and let's install the Istio base first. I'll be using Helm. So Helm install Istio base or Kind cluster 1. And after this is done, we need to install Istio base for cluster 2 as well. Cluster 2. So now both our clusters have Istio base on Istio system namespace. Next thing, we need to install Istio-D, and for that, let me show you the cluster.yml file that I'll be using. So this is the minimal setup we need for setting up the multi-primary and multi-network cluster. Here, mesh ID is mesh1. This is the name of the mesh, and multi-cluster, cluster name, cluster 1. So I'm giving the cluster 1 Istio cluster name as cluster 1 and network 1. So our cluster 1 will be using network 1, and similarly for our cluster 2 we have network as network 2 and the cluster name as cluster 2. The mesh ID will be same, mesh 1, because we are having the same mesh. Basically we are using the same mesh. So let's install Istio-D with these configurations. So Helm install Istio-D and using cluster.yml and in cluster 1. Let's install it. Okay, so Istio-D is installed on cluster 1. Let's install in cluster 2. Okay, Istio-D is installed on cluster 2 as well. Next thing, we need to install Istio gateway. So this will be work as a east-west gateway for our cluster, and this will accept the incoming traffic. So the command is simple. Helm install Istio ingress gateway, and I'm using east-west gateway.yml. Let's check out the YML file. So here is the YML file. We are setting up some labels, especially that topology.istio.io network as network 1 for cluster 1. And we are exposing couple of ports. So here TLS. So our communication will happen over TLS and port 154443. A couple of other ports, 15012 for Istio-D, 15017 for webhook, and 15021 for the status check. Let's create the east-west gateway. So I'll be running this command. Similarly, we will create one east-west gateway for cluster 2 as well. The cluster 1 east-west gateway will accept the traffic for cluster 1, and cluster 2 east-west gateway will accept the traffic for cluster 2. Let's give it a moment for gateway to install. Okay, now our cluster 1 gateway is installed. Let's install in cluster 2. Now our gateway is installed in cluster 2 as well. Now, since the clusters are on separate network 1 and network 2, we need to expose all the local services on the gateway in both the cluster. So we need to expose the services. I have a YML file for that, expose services. So here the kind is gateway, metadata name is cross network gateway, and selector east-west gateway, port 105.443, and protocol is TLS. So services behind the gateway will only be accessed by the services within a trusted TLS certificate. So we are using TLS. TLS mode is auto pass through and host is start local. So with this configuration, we will expose the services. Do that. First in cluster 1, kubectl apply is your system namespace and providing the expose survey.yml file. Once it's done, let's do the same for cluster 2. Let me just change the command and done. Now we need to enable the endpoint discovery. So cluster 1 Istio control plane should have knowledge of cluster 2 endpoint, and similarly cluster 2 Istio control plane should have knowledge about cluster 1 services. So in order to do that, we need to create a remote secret for cluster 1 and cluster 2. Let's do that. So here is the command. I am doing istio create remote secret, and this will create the remote secret and store it in API server.yml file. Let's do that. And similarly for cluster 2. Change this to cluster 2 and name cluster 2 text cluster 2. Okay, so it has created. Now using this remote secret, cluster 1 will have knowledge on cluster 2 and cluster 2 will have cluster 1. But before we apply that, let's first check the generated file. So here you can see this is the generated server.yml file. It has all the information, but here we need to make few changes since it's localhost 127.0.0.1, and if you are using a Kind cluster, the local localhost address, this will not be accessible by cluster. So this will not be accessible. So when cluster 1 is trying to access cluster 2 API endpoint, this localhost will refer to its localhost within the cluster. So we need to make changes in this. We need to change this to cluster 2 -5 control plane port 6443. Sorry, this will be cluster 1. And similarly, we need to change for cluster 2 as well. So here we need to change to cluster 2. So this change we need to make. Why we are changing to cluster 2 control plane? Where it's coming from our Docker desktop. You can see the cluster name is cluster 1 control plane, cluster 2 control plane. So now when cluster 1 will try to make the connectivity with cluster 2, it will be using cluster 1 control plane on this port, and this will resolve to the cluster. So localhost or 127.0.0.1 will not work. We need to change to this. Now let's apply this. So I am applying on cluster 2 API server.yml on cluster 1, and similarly vice versa, we need to apply cluster 1 API server.yml on cluster 2. So now both the cluster have knowledge of each other. So with this, our multi-cluster setup is done and both the clusters should be connected with each other. Let's verify two things. Now kubectl get all Istio system text one. So here we can see our Istio D is running, Istio Ingress Gateway is running. Istio Ingress Gateway has type as load balancer and it has external IP. Let's check in cluster 2. Here also we can see Istio D is running, Istio Ingress Gateway is running, and it has type load balancer and external IP is assigned. So this looks good. Now let's verify that the multi-cluster is properly configured. To do that, we will create services in cluster 1 and cluster 2. A simple hello world app we will create and we will test the connectivity. Let's first create the namespace Istio sample in both the cluster 1 and cluster 2. This is created. Now, when we deploy services, we need to label the namespace as Istio injection enabled so that Istio will inject the sidecar. Do that cluster 1 and cluster 2. Now let's create the deployment for hello world app. Cluster 1, cluster 2, the services. And now let's deploy. So we are deploying hello world version v1 in cluster 1 and v2 in cluster 2. So both the cluster have hello world app, but a different flavor. The version 1 is in cluster 1 and version 2 is in cluster 2. And now with it, let's deploy the sleep app in both the clusters. Okay, both are created. Let's check. Your sample text equal to kind body. So our services are coming up. So hello world is up. Sleep is initializing. Let's give it a minute. Let's check the same in cluster 2. Cluster 2 also is still initializing. Let's wait for a couple of minutes. So now we can see both the hello world and sleep are ready in cluster 1. Let's check in cluster 2. Cluster 2 also has hello world and sleep up and running. So now we have this sample app available. What we need to do is we need to make some API calls and check that the calls are going to both the clusters. So basically cross cluster connectivity is happening. I have this command here. So basically this will this command kubectl execute in kind cluster 1. It will go inside the sleep pod, and from sleep pod it will make a call to the hello world app. Here we can see hello world, and what we are expecting is when we make this call multiple times, the call should go to both the clusters. So there is a load balancer. It should go to hello world in cluster 1 and cluster 2. So we should see two different outputs from two different services from cluster 1 and cluster 2. So let's see. So first I am executing this from cluster 1, and as you can see from cluster 1, and we are getting a hello world response v2, which is coming from cluster 2. So that means from cluster 1, calls are going to cluster 2. Now let's do it again. We will do it several times and we should see that the call are getting to both the clusters. Now we get a v1. So basically this means our calls are going to both the cluster. V1, do it couple of more time, V2, so it's going. Couple of more things. If you are not able to see this, you can check the envoy proxy logs in order to check that your setup is correct or not. So let's try that out. To do that, first see the ports, MPL, so find the sleep pod. Here we have the sleep pod, and then run istio proxy config endpoint command, and we'll need to change this pod name. And what this command is doing is it's giving us the envoy proxy configuration endpoint for a sleep pod. And let's see. So here you can see we have two endpoints here, both are healthy. One is 10.244, that is local, and another one you can see here. This is the cluster 2. It's running on 15443. If you see only one, that means there is some issue with your multi-cluster configuration, and those clusters are not able to talk to each other. But if you see two, that means it's working as expected. So this is installation step for multi-cluster, multi-primary, and multi-network Istio configuration. Thanks for watching.